Hello, my name is Richard Jacklin and I'm the Director of ViaLite Communications. ViaLite is a manufacturer of RF over fibre technology and platforms, and in this short video I'm going to explain what RF over fibre is as a technology and how it's used. Okay, so let's start at the beginning. What is RF over fibre? Well, in a short sentence, it's really a coaxial cable replacement product. So we're all familiar with RF coax cable. Typically it's a 50 ohm or 75 ohm product. We see various different ends. This is a BNC type connector that's quite commonly used. It's used everywhere, in the home, in industry. It's a great product. It's cheap, readily available. But as you go up in frequency, up in the spectrum, and as you go longer in length, you tend to get longer and bigger losses with this type of product. And for short distances, it's not a problem, but for longer distances, this can become a problem for users. So the alternative to that is a product, fibre optic cable. We all know about this. It's in the street. It's now connected to many homes around the world. This is a great product. In terms of losses, it has a kind of a loss capability of a magnitude less than the humble coax. So we can go kilometres or tens of kilometres with this, where with a coax you might be limited just to tens of metres. Fibre optic cable also brings with lots of other benefits as well. So it's immune to high energy electromagnetic interfering type environments. Because it's kind of a plastic and glass product. It means that it provides isolation from things like lightning strikes through to sensitive equipment. You can see here it's a lightweight product. It's easy to install. It's quite cheap. And when we actually put a radio signal over it, we actually get very good dynamic range, great phase and frequency response. So really RF over fibre is built on using the benefits of fibre optic cable. So let's dive a little bit deeper now into RF over fibre and how it works. So we've talked about the bit that connects it in between, which is our fibre optic cable. So the other parts of RF over fibre is actually made of two parts. We have a transmitter, which is the RF and the electrical conversion into optics. And at the other end, we have the receiver, which is the optical back into RF and electrical. And just to sort of demonstrate that a little bit better, this is actually a transceiver product. So it has a transmitter and a receiver on the same card, the PCB card that we have here. On the lower section here, we have the transmitter. Just behind this metal collar is a laser. And actually that is the core component that does the conversion from the RF electrical energy into optics. And in RF over fibre, we intensity modulate that laser to actually move that RF energy into the optical world. On the other side, on the receiver side, we have this product here. You may be able to see it. This is a photodiode, and that's the core component that moves the optical energy back into RF. You can see that on this particular PCB there's other capabilities. We have dip switches here which can control things like gain or automatic gain control, or if you need to put power onto the RF cable. This type of product is also chassis based, so it connects into a chassis and a controller, which is typically SNMP enabled. RF over fibre though can come in lots of other different form factors. So this type of product here is a single receiver or single transmitter in a much smaller self-contained unit. So lots of different ways that this can be formatted. So as I previously mentioned, in RF over fibre, we use intensity modulated lasers. And what that actually gives us is a modulation agnostic conversion capability. So it actually enables us to use this type of technology across a very, very wide range of wireless and radio application. So you'll see RF over fibre used very heavily in SATCOM, connecting the dishes, particularly in gateway sites, through to the network equipment rooms. We use it in broadcast, connecting wireless cameras and microphone systems back to the production desk. For GPS and GNSS systems, taking those signals, which can normally be seen only outside, to indoor locations, such as underground transport, for instance. We used lots in aero and defence applications, maritime, radar. Basically, the list is pretty much endless. So if you're interested to see more around the applications and use cases for RF over fibre, you're very welcome to visit our website, ViaLite.com, where you can find out more about those and also about our products. Anyway, hopefully this video has been helpful, and look forward to seeing you again soon. Thanks.